Yeah, exactly. Exactly, Creel. That's the perfect idea. That's what we do. Okay, so today we are starting with Learning Unit 5, and if we have time, we'll go back to the end of Learning Unit 4, which honestly I don't think is necessary because it's all just theory from the point where we stopped. We stopped with, let's just check, we stopped with all the binary stuff. We were about to start, yeah, we're about to start ASCII and basically different methods of encoding, how binary encoding is used mostly for string variables now rather than numbers. ASCII, Unicode, UTF, all this stuff, it might look like a little bit of complicated stuff, but it's not. It's theory. So this is all stuff that you guys can read by yourselves. Unfortunately, in 1 hour a week, there's not much we can do with this stuff. And also there's this cool section here that shows you how binary numbers are used to represent colors on pixels. That's an interesting section. So if anything, if there is some time, maybe I'll start here because this is a bit interesting. It gives us some kind of visual stuff apart from all the numbers we've been dealing with. All right, but anyway, hopefully we can finish this learning unit today because it's actually not much. It's not much, but maybe the examples get a bit involved, so I'm not going to rush it anyway. So learning unit 5, the main thing we deal with here are truth tables, which again, as I mentioned, it's a similar thing to logic gates, except they don't make that link at any point here, but just keep that in the back of your minds because I'm sure you guys will see logic gates later in your degree. That's important for programming. So if you see it and you learn it from the bottom up, you probably won't even realize that it's the same thing that we are doing here. So just keep that in the back of your minds. Logic gates and what we're doing here, which are truth tables, are pretty much the same thing. Not pretty much, it is the same thing. We just sort of label things differently with different names. Like here we say true and false. There in logic gates, they will say 0 and 1. Same idea, right? No difference. All right, so anyway, let's get started defining things before we go ahead. Symbolic logic and proofs. Okay, so proofs we will see later. We're going to start with symbolic logic. And first, we need to define what an argument is. So these are annoying things we just have to remember. Okay, so an argument is a set of statements, one of which is called the conclusion and the rest of which are called the premises. So those are two things we have to remember. Premises is the first thing, and then from the premises, we can draw a conclusion. And now the word argument, we must remember, argument is the sort of the topmost heading here. Argument has two subsections, conclusions and premises. And now if you want to know whether an argument is valid, how will we deduce an argument is valid? It's valid if when the premises are true, then the conclusion is true, right? So that we have to remember. So an argument, let's write this here. Argument, we have premises. I'm just going to say PREM and conclusion. Okay, should I put an arrow there? That might be misleading. Let's just put a dash there. So argument is, change color for this one. This is important. It will come up a little bit later, but we have to remember this. A valid argument is if you have, okay, the premises could be more than one. So I'm going to say premise, singular, plural. So it's valid if when this is true, this is also true. Right, so that we need to remember. When the premises are true, the conclusion is true. Basically, both of these are true at the same time, then it's valid. Okay. This little box here is important. We need to review some stuff from, where was this? Learning Unit 3, I think. This irritating stuff we did in Learning Unit 3. We have to remember a little bit of it before we go to truth tables. So this purple part here is recap. I've copied and pasted from Learning Unit 3. It is just a bit of recap of how statements interact with one another and what truth values we get from statements, right? This may sound a bit like nonsense at the moment because it's been a while since we looked at this. But if we just look at a few of them, we'll see it's quite straightforward. So for example, let's look at the first one here. This is an AND statement between between P and Q, where P and Q are individual statements. Again, if you look at examples, it makes it easier. P could be something like the sky is blue. Q could be something like the grass is green. It doesn't matter. We can pick any statement. It doesn't matter what it is, right? So what we're trying to work out here is when is the combined statement P and Q, this upward triangle is like this little thing here called an upward triangle. It basically means and. So this combined statement P and Q is true under the conditions stated here. So both P and Q must be true. Then only the combined statement P and Q is true. Right? So maybe we should look at one example here just to, in case anyone's losing the stuff a little bit. So let's say, I don't know, let's say the simple one. P is the sky is blue. Q is, let's say, it is cloudy. And I'll phrase this as a question. So the question will be, if, I'll say, if your weather app, I'm not going to spell weather, it's going to take too long. If your app says that, how do I phrase this? There are a few clouds in the sky and the sun is shining. I'm overkilling this thing now. Then is, okay, we need to label these statements. What was it? There are a few clouds in the sky and the sun is shining. Yeah, then is P and Q true? Yeah, so let's leave it at that, right? Okay. So we need to first know whether P is true and whether Q is true. In the form of this question, it's clear. Oh, why did I say the sky is blue? Sorry, guys. P should have been the sun is shining. That's what I meant to say. I'm hoping you guys are getting what I'm trying to do here. The sun is shining. Okay. Now let's read this again. Sorry about that. Okay. The question says, if your weather app says that there are a few clouds in the sky and the sun is shining, then is the combined statement P and Q true? Is that true based on the individual truth values of P and Q? So what do we know about P and Q? Is P true? Is the sun shining? Yes, it is. We told that in the question. We are told this clearly. And Q, is it cloudy? Well, the app says there are few clouds in the sky. So sure, it's cloudy. We have clouds in the sky. So both of these individually are true. So what does that say about the combined statement? For that, we have to look here. The combined statement is true when P and Q are both true. So that means yes, this is true. Okay, I'm hoping I didn't lose anybody there. Just let me know if anyone is lost or you need further clarification on this. This is just a bit of a recap. Okay, let me just check how people are doing here. Anyone saying anything? Maybe I should keep the example visible so you guys can think if you're thinking. Okay, again, just interrupt me if you need to. Let me remove all this nonsense from here. Okay, and all of these work in a similar way, right? This is just one example for and, but we could have done this for any of them. The first one is and, second one is or, this is if then, this is if and only if, and this is the negation or not. So that's what those are. Again, you guys can recap that from learning unit 3. It's all there in detail. Now, truth tables at the bottom in green, this is the new thing. So this is the new thing. And perhaps this is even easier than what we did in learning unit 3, because here it's all very straightforward and logical. You don't have to think about sort of interpreting statements and stuff like that. So these are basic truth tables for each of the logical we see above here. right? You'll notice each has a corresponding. So if this first one, the AND is number 1, this first truth table corresponds to an AND. Number 2 is for the OR. The second truth table corresponds to that, and so on. The third one is for the if and only if. Fourth one is for the if then. The fifth one is for the negation. So we just do one example for each just to get a basic feel of how we start working with these things. Okay. So the first one, we see the first column is for the statement P, and we see what they've done is given us every possible value of P, right? That they could only be true and false. A statement can only be true and false. And the same is true with Q. In the second column, we see every possible value of Q. And they repeated, but that's only because what we want to get in the end is every possible combination of true and false for each of these two variables together. Like notice, look at the first column here. Sorry, the first row here. Both of them are true. Second row, we got one true, one false. Third one, sorry, we have the other false and the other true. Then we have both false. So these are every possible combination that you can get. That's all they're doing here. They're just trying to list every possible combination. And based on every possible combination, we need to use the rule described in the purple box above to fill in the last column. Okay, so let me do the first row where both P and Q are true. If we know that both of these are true, then the molecular statement P and Q is also true. I get this directly from reading the rule above here that I'm highlighting. Just by reading that, that says this statement is true when both P and Q are true, right? So that's clearly met here. For this row, P and Q are both true, so that's true. The combined statement is true as well. Okay, what about the next one, where we got P true and Q false? Now let's read the rule above and see if that satisfies our condition for the molecular statement to be true. And clearly it doesn't, right? We need both P and Q to be true. Only in that case, the molecular statement is true. Otherwise, it must be false. In fact, no other combination here gives us a double true. So all of these will be false. Okay. Now, number 2 here is dealing with an OR statement. So when is an OR statement true? Let's go to the relevant rule here. I'll highlight it as we go. So this is true when P or Q are true. So as long as one thing is true, this entire molecular statement is true. All right, so look at row 1 here. We have both true. Clearly that means at least one is true. So that's perfect. Second row here, we have P is true. Even though Q is false, it doesn't matter because the rule above says as long as one of them is true, it's good enough to say true. And we got the same story down here. Q is true, but even though P is false, it doesn't matter. Q is true, so that's good enough. One thing is true, so the entire thing is true. And the last row is the only thing where we meet no criteria. P is not true, Q is not true. So none of the conditions are met, so this must be false. Okay. All right, so those two are the easy ones. So I'm going to give you guys a few seconds to just look at them, digest them. Let me know if there are questions, because from 3 it gets a little bit confusing. Just a little bit, not too bad. I'm just going to keep quiet for a few seconds. All right, so let's go ahead to number 3. So for number 3, we're using the rule 3, which is the one I think people had a bit of trouble with because it's worded in a strange way as well. So this is called an implication, in case we've forgotten that word. So an implication is true when P is false or Q is true. This or both here doesn't really serve a purpose. I just take it out. It confuses people and it doesn't help us. So the implication is true when P is false or Q is true. now it seems simpler. That's all we need to worry about. Forget about the meaning, forget about interpretation. Don't worry about where it comes from. Just let's apply it. That's all. Okay. So first row, both of these are true. Let's look at the rule and see if that helps us. So it's true when P is false, so we don't meet that part. P is not false here, so we don't meet that. Or Q is true. Do we meet that part? Yes, we do. We have a Q here, which is true, so that's perfect. We just need to meet one condition. We meet one condition, it's good enough to say this thing is true. All right, now row number 2. Again, we go back to the rule above. The rule above says the implication is true when P is false. Do we meet that? No, we don't. Or Q is true. Do we meet that? No, we don't. We don't meet any of them here. So let me just say that again. I'm reading the rule above. The rule above says the implication is true when P is false. I'm looking down at row 2. Is P false? No, it's not. The rule above then says if or Q is true, right? Is Q true here? No, it's clearly not. So none of the conditions are met, so we say false here. All right, so let's look at row number 3. Oops. Row number 3. Again, I look at the row, then I go back up to the rule. The rule says implication is true when P is false, and that looks like it's met already. P is false right here. So we don't have to even check the second condition. As long as we meet one condition, it's good enough to say true. Right, we met the first part. P is false, so that's good enough. We stop there. All right, so row number 4. Row number 4, let's go back to the rule. Implication is true when P is false. Okay, we met that. P is false. So we don't have to look further. Doesn't matter. So this is now true. All right, maybe these circles are helpful as well. It shows us where we met the condition. Okay, and just in case you're interested, for the third row, we met both conditions actually. It doesn't matter because we just need to meet one, but we did actually meet both of them. All right. Okay, and number 4 is an if and only if. So this one we don't work with so often, but again, the rule is there, so we can always just read and pull the table in, just following instructions. Okay. So the if and only if, I forgot the word for this. I think it was, yeah, it was biconditional. That's the word. Okay, so the biconditional is true when P and Q are both true or both false. That's quite an easy one, isn't it? Just look for places where you got both true. That's clearly only the first row. And places where you have both false, that's clearly only the last row. Those are the only places where we get true according to the rules. So everything else is just false. Okay. And now we look at the negation, which is the last one. Number 5 is the easiest one to do. Negation is just, we don't have to even worry about the rule here. Negation, it just flips the original value. So look at number 5 here. True becomes false, false becomes true. That's all that happens there, nothing more. Okay. I'm hoping you guys are getting a bit of a flavor for this because now we start doing examples and we start building these tables up a little bit more. Okay, we have corrections here just in case everything is, let me just make sure these things are fine. True, false, true, true, and true, false, false. Okay, perfect. No problem. So we have everything that we need. So now we ramp it up one step, just very slightly, not much. Make a truth table for the statement not P or Q. Not P or Q. So we always start with the bare minimum base variables, right? So that will be P and Q here. So we'll start with the P and Q. From there, we increment it as small steps as we can so we can see what's happening, right? So the next increment we will make is a not P. And we can't make any more increments. At that point, we just put the final thing, not P. and Q. Right, you see I've taken it as small steps as I can. Now filling in these tables, the first part is always standard. Let's just draw some lines here. Yeah, I picked a bad color, but anyway, I should have done this the opposite way around, but it's fine. So the P and Q, we always fold them in the same way. You do a double true, double false, true, false, true, false. Okay. It doesn't matter which order you do this. You could do the P true, false, and the Q true, false, false. Doesn't matter. As long as you do it in a way where you get every possible combination of true and false. Is this consistent with what we did above? Yeah, it is. Okay, just for convention, but again, it doesn't matter. So now we just fill this in very simply. The not P is just going to be the complete opposite of what P is. So maybe I'll change color for this because this is the actual values we're filling in. The first two are just standard. That doesn't change. All right. So not P is going to be the opposite of P. If P is true, not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. Okay. And now this becomes straightforward because once we have not P, this entire thing is just here. We don't have to consider now we need to work out what not P is because that's done already. So essentially the truth table is just for this here now. We don't need to look at the P anymore. Hope you guys get what I mean. This is just now, it's equivalent to, is this on? Or it's equivalent to this right here. It's as if we just relabel the variables, right? Because not P is now just a thing by itself. We could relabel that as another letter. Not P could be, I don't know, let's say F, for example. And sometimes that helps people. So I'm going to write that on the sideline just in case that helps you. Q, not P, I'll call it F. Okay, actually, it's a terrible name. I didn't realize how bad that was because F is false. Let's call it, I don't know, let's make it U, for example. Then the last part is going to be U or Q. And then we just do the thing. But again, this step is, you don't have to do it. You can work with the original, but if people are getting confused, this is a helpful trick. So Q we have already. We know it's just true, false, false. U is just a substitute variable for not P. So we just fill in whatever the value of not P is. It's false, false, true, true. And now the U or Q, the last part is easy. It doesn't look difficult anymore. And what's for the truth value between two statements and then or, we know that this thing is true as long as we have one of the individual statements to be true. So as long as Q or U are true, then this entire thing is true, right? So the first row I see Q is true, so that's good enough. Second row, nothing is true, so that's not good enough. Third row, we have double true, so that's perfect. Last row, we have U is true, so that's good enough. Right? And you can just take these values now and paste them back into the original table. True, false, true, true. True, false, true, true. Right, so again, you have two options to work with. Let me take out these outlines now, these big circles. Take that out. Take that out. And you have options now. You could work with the one on the left or the one on the right, but it's exactly the same thing. Okay, I'm hoping I didn't lose anybody. And also, most of you probably can work with what's on the left, but if you start getting confused, don't be afraid to use what's on the right. That's perfectly fine. Okay. All right, I'm hoping we're okay with this because I think it ramps up quite a bit here. Let's see. Yeah, okay. This is a bit of a longer one. Let me just check the chat. Any problems? Anyone bothered by these? Okay. Uh, yeah, it's always helpful when someone just talks you through these things that are Seemingly difficult, but not really. All right. So now let's try this one. Oh, I hope I can do this one. I just see these words and I start getting panic attacks, but I'm sure we can do this. Okay, analyze the statement. I think this deals with Monopoly. Yeah, the statement is, if you get more doubles than any other player, you will lose. Or that if you lose, you must have bought the most properties. Okay, so we need to first make some labels here. If you get more doubles than any other player, you will lose. I think that's an if-then statement. So if you get more double, oh, that's a bad color. Let's use blue or something, or red is more distinct. If you get more doubles than any other player, maybe there should be a comma there. Oh, wrong place. Half asleep here. Comma, you will lose. So that's like a if P then Q situation. So you get more doubles than any other player is one statement. How should we label these? Do I have to write the whole? Yeah, maybe. Okay. So we'll say P is you get more doubles than any other player. Okay, then Q is you will lose. Okay, that's clearly an if-then statement. Then we have another statement coming after an or, and it's another if-then statement after the or. So if you lose, what should we call this? PQ, let's just make it RS. If you lose, or we have you lose already, right? So that's Q. So that's Q being repeated. So that's okay. We don't have to label it as R. What I just underlined is just Q again. So that's okay. But after you lose, what happens? If you lose, then you must have bought the most properties. So that's a new statement. So we'll call that one R. You must have bought the most properties. Okay. Okay, so only three statements. Yeah, maybe it's not too bad. Let's see what happens. So analyze the statement. When they say analyze the statement, usually they mean using truth tables. I think they tell us here at the end. Yes, they do. So just make a truth table for these statements, P, Q, and R. So let's do the first thing where we get every possible combination of P, Q, and R. Then we'll start building it up further. Let's change color for this part. P, Q, and R. And this is where I can already show you guys something a little bit new. Because we have three variables, we have to have more than 4 rows. I think there was a rule for this. It was something like 2 to the power of the number of variables gives you the number of rows that you need. Let's just see if that makes sense. So if I had one variable, there'd only be 2 rows. So 2 to the power of the, let me just say, number of variables equals number of rows. Let's check if that works out. So example, if I had one variable, just say, if I had one variable, then I'd need 2 to the power 1, which is 2 rows, right? That makes sense because we saw that here, one variable, just P, we have 2 rows. So that works out. If I have two variables that have 4 rows, that's clear. So for two variables, we'd have 2 squared, which is 4 rows. So that works out. So for three variables, we must have 8 rows. So 2 to the 3, which is 8. Okay, and I can see in my head that that will work out because I've done this about a year ago, but at some point I did these. Okay, so we must have 8 rows here. And let me make a lot of space because we don't know how much stuff we're going to fill in here. So it's 1, 2, 3, 4, 6, 7. I think that's good enough. Yeah, because the last one will be the 8th. Okay, and now to fill in every possible combination, okay, let me stay with black for now. You don't have to always start like this. There's no set rule how to do this. You just need to get the combinations properly. But one way I like to do this is, okay, I'll change to blue for this. The first row, the first column, just do a perfect half and half split. So if we're working with 8 rows, just do 4 of them true and 4 of them false. And then for the next one, just make a subdivision, right? By subdivision, I mean, look at this. We can break it up into half here. Oh gosh, why did I do that? It should be one lower. A half between the trues and falses, right? I hope we can see that clearly. And in that half, or the Q, just make half of them true and half of them false, right? So work on the upper half first. For that upper half, we have 4. So from that 4, make 2 true and 2 false. For the bottom half, do the same thing. 2 true and 2 false. Right? And we just keep subdividing like that. For the next one now, we can divide into quarters, right? There's the trues there, there's the falses there, there's the trues there, there's the falses there. So in each of these subcategories, just make half of them true and half of them false. There's only 2 here, right? Only 2 per category. So 1 true, 1 false. Another 2 down here, 1 true, 1 false, and so on. Right? That's not the only way to do this, but it's one way to make sure you quickly get all your categories. Okay. All right, so once we have this, let's see what is the ultimate statement we are working out here. Well, it's just the thing in the question, right? So what does that look like? Let's write it somewhere above so we know what we're working toward. If you get more doubles in any other place, so that's an if statement already. It's an if-then statement. So if you get more doubles in any other player, so you get more doubles than any other player is P. So if P, then what happens after that? Then you will lose. You will lose is Q. Okay. So now after that, we get an OR here. So OR is, which one was it? Downward triangle, right? Yeah. Or if you lose, what was you lose? It was Q. So if you lose, then you must have bought the most properties. That's R. So I hope you guys see how I constructed that. Literally just reading and writing as I read. Okay. Yeah. So again, if you guys need me to recap that at any point, just let me know. For now, we know what we're working toward. So we try and break this up into subcategories now. So let's see, what's the smallest logical step we can take? I guess we can do the if P then Q. So I'll write that first. If P then Q. Next, maybe we can do the if Q then R. So let's do that next. If Q then R. And lastly, well, that's all we need, right? The next step, we can just do the entire thing. So let's write the entire thing. Okay, that's an O between Q and R. Okay, that should be an arrow. And there's just about enough space for the entire thing. All right, so now we can fill in the table. And the only things we have here, really, the most prominent thing is the if-then, and that's a slightly confusing one. Okay, so what's the rule now? Let's try and remember. If P, okay, let's write it somewhere again, a different color, so we don't lose everything in color. So if P, then Q, what was this thing? So this is true when P is false, is the first condition, or Q is true. But now this might be confusing because I'm using P and Q here, And some of our variables, we have a Q and R here, so that's going to be confusing. So, okay, this is the rule. There's nothing wrong with it. But let me change the labels to something completely different so we can keep on substituting different things. Because if we have to substitute a R for a Q and a P for a R, and weird things like that happen when we already have the name. So let's make it, what don't we have here? Let's say S and T. So let's say ST, and this will help us not get confused. Okay, so oh gosh, why am I using T when T is true? So let's say S and U. Any objections? Let me think. My brain is not working today. I think that's okay. Yeah. So this here is true if let me not write it like that. So let's put a double dot here. So this is true if S is false or U is true. See, I'm taking a while because I'm translating the P and Q in my head into the new variables, S and U. So I know it should be P is false or Q is true. So, okay, so this is perfect. So this is the one we need. All right, so let's do the thing. Now we can do it. Let's go back to red. So the first one, let's see. If P, then Q. So we need the first statement to be true. Sorry, we need the first statement to be false or the second one to be true. So, okay, let's put the label up here. We need the first one to be false or the second one to be true. So now let's just see what matches that. Okay. So in the first row for P, we have a match here, right? That one matches. Q is true. So as long as we match one of them, we can say true. Okay, second one, we have that same match. So that's true. Third one, we have no match, right? We don't have the first one false or the second one true. None of them match, so no, doesn't work. False. Okay, last one, anything matches here. It's the same thing, right? So it doesn't match. So that's also false. The next one, we have a double match, false and true. Perfect. Again, double match doesn't matter. As long as we get a single match, as long as at least one thing matches, we're good enough. But we're just acknowledging the double match, which happens twice here, including the next row. So perfect. Next one, we get a single match. That's good. And then finally, we get another single match. So that's good. Yeah, I'm going to have to erase all these circles I made at some point. It's going to be distracting. But anyway, we're good for now. Okay, so let's do the next one. If Q, then R. Maybe I'll do that in a different color so I don't have to erase all these things. All right. So for this one, we need the first statement. According to the rule above, we need the first statement to be false or the second one to be true. That's why I use these different variable names here so we don't lose them. So the first one here happens to be Q. So we need Q to be false, or we need the second one, R, to be true. So now we just look for matches here in the green part. So let's see. First row, I have no match. Oh, no, actually I do. There's a match right here. So that's true. Afterward, second row, no match. Third row, double match, right? We got a false and a true. Double. Oh, I must have false up here, sorry. Anyway, yeah. So double match here. False and true. Then we got a single match in the next one. That's true. Next row, we have, why is my head not working now? Yeah, we got a one match here. One match, right? So that's true. Then we have no matches that I can see. True, false, exactly the opposite of what we need. So there's nothing here. Then we get a false true, which is exactly what we need in both cases. Again, we only need one of them, but if we meet both, that's fine. And finally, at the bottom, we meet only one of them. Perfect. That's all we need to say true. Okay. Again, you guys don't have to draw all these circles and do these weird things. It's just I'm showing you the most effective way to make sure you don't make mistakes, at least in the beginning stages. All right, now we can do the final step. And the final step has us put an or statement between the two that we just worked out. Okay, so we can do the trick that I showed you above to rewrite everything and make substitute statements. But when these tables get bigger, it becomes a bit of a nuisance to do that. So let's try and work with this one as it is. All right, and maybe we should change color one more time. We're running out of colors here. There's a weird yellow here. I don't really like it, but let's go with it. A bit light. Brown is a bit ugly. Yeah, let's do it one more. Okay. So now what's the rule for one? Or. We just need one of them to be true for an or, right? As long as we get a single true in the things we're looking at, that's all we need. So for now, we only need to consider this part here. Forget about the rest. So our statement, if P then Q, or if Q then P, if Q then R, sorry, that big statement right at the end is true if we get anything else, if we get anything to be true per row. So let's go row by row. If we have a single true, then we say this is true, right? You see here, both of these individual statements are true, so this is true. Here, the first statement is true. That's good enough, so we say true. Next row, one thing is true here. The second one is true, so that's good enough. We say true. Next one, we have a true there, so that's true. Here we have double true, so good enough, true. Another true somewhere, so it's true. Again, see, anywhere where I have any true at all, it's good enough to say true. So everything turns out to be true here. And that's good because that's what we wanted to get, right? If I remember correctly, this is what we wanted. Okay. So this is a bit of work, but once you just need to practice a bit and you'll get used to it. And we also learn one new word here. The word is a tautology, right? We see the word highlighted at the bottom. So let me just read the definition instead of trying to remember it. Statement of monopoly is example of tautology. Tautology is a statement which is true on the basis of its logical form alone. So that means no matter what you say about these individual P, Q, and R, it doesn't matter because no matter what you say about them, whether they are true or false, doesn't matter. The end result will always be true for this big molecular statement. Right? That's what the truth table is telling us because think about it. We looked at all possible values of PQR in the first two columns, every possible value, and no matter what we put in, the output is always all trues. So it doesn't matter what you say in the beginning, the result will always be true at the end. And that's what a tautology is. Okay, and just remember that word because I'm sure they will ask you about that in the paper. Okay, right. That was a bit of a big one, and now, yeah, there's more to do, but that was the one I wanted to get through because everything else you guys can do on your own if we don't finish it. Okay. So we're looking at logical equivalence here. Here we just need to know a definition. Logical equivalence is just something we can say when comparing two statements. So two statements are logically equivalent if their truth values are exactly coinciding, right? For example, let's say if I had, I don't know, R and N, these are two statements, and the truth values look like this. True, true, false, 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 true, true. Right, you see they're exactly the same. If you get that, then we can say that these two are logically equivalent. Right, so R and N could have been anything. Maybe they substitute variables for something bigger, something like PQ and I don't know, T Yes, again, I'm using T, but anyway, you guys get the picture. R and N can be anything. I'm just using variables here to represent something. Okay. So let me try and do one more example before we end. Which one is useful? This is probably a good one, but maybe let's try this one here. The one at the bottom you guys can do. Okay. Let's put a better color now. This thing is disturbing me. So are the statements, it will not rain or snow, and it will not rain and it will not snow, logically equivalent? Are they? I don't know. Let's find out. Okay, so the first, let's make P and Q and R and S and whatever we need. So the first one, it will not rain. Let's call that P. I'm just going to write it up here. Okay, actually that will be not P, because P will be it will rain. So I'm just going to make that label. P is will rain. If that's the case, then it will not rain is not P. Is this okay? It will not rain or snow. I'm trying to think for a second. And it will not rain and it will not snow. Okay, so this is just phrased in a bit of a weird way. Again, this is like dissecting English a little bit here. So let me just write it like this. It will not rain or snow will be more like, okay, I can't escape it. I have to write it like this. Say P will be it will rain, and Q will be it will snow. Then this first part here can be something like it will not rain or snow. All right, that's the first part. It will not rain or snow. Okay, so that's what I did there. And the next one says it will not rain. So that will be more like it will not rain. This is an and now, not an or. And it will not snow. Okay, sorry, the first one I put the wrong triangle, but yeah. First one was an or. Second one is an and. Okay, so these are the two statements to analyze using the truth table. And this is going to be a bit of a long one. I can see that, but I'm going to do it a bit quickly. It's on video, so you guys can go back if you need to. So we need a P and a Q here. Okay, so that's not too bad. It's just two variables. So 2 to the power 2 of rows. That's 4, right? So just 4 rows. So I'm going to say P, Q. Then we try and make small increments here. We'll then say not P, not Q. And then we can say, next we will need a P or Q for the first statement. How do we then increment that? Then the next step will be the final things, I guess. Yeah. Then we can say not P or Q, and then we can say not P and not Q. Okay. Again, you guys will get used to incrementing these appropriately. Sometimes if you miss one step, as you're filling the entire thing in, you'll realize, oh, I don't have a piece of information that I need. Then you go back and fill in what you need, right? I've just gotten used to that, so I can do it in one go, but some of you will probably see it already. It's not too difficult. Just increment as much as you can. Okay. So let's fill in here the 4 rows, 1, 2, 3, and 4. Okay, so we do the usual thing. At the beginning, we say true, true, false, false, true, false, true, false. Now in 5 minutes, can I get this done? And that's a challenge. Let's do it. Okay, not P is just the opposite of P. So true becomes false, true becomes false, false becomes true, false becomes true. Not Q is the opposite of Q. So true becomes false, false becomes true, true becomes false, false becomes true. P or Q, we know that this is true if any one of those two things are true. The first row we have double true, that's perfect. Second row we have one of them true, that's good enough. Then we have one of them true again, that's good enough. Here none of them are true, so false. Now, this part here is easy because we've done P or Q. So not P or Q is just the opposite of what we've done already. Just take what I've done here and I just flip it around here. True becomes false, true becomes false, true becomes false, and false becomes true. All right. And the last one is just an and between this and this. So an and is true if both are true, right? Yeah, if both of those things are true, then the and is true. So any other case, it's going to be false. Are both true in the first one? Nope. Second one? Nope. Third one? Nope. Last one? Yes, both are true in the last one. So the question was, are these two things here logically equivalent? I think you guys will be able to see clearly here that yes, they are very clearly. As long as the truth tables have the same values, then these two statements are logically equivalent. So here we meet that. That's perfect. Okay, and I said I'm going to struggle to finish this in 5 minutes. I did it in 1 somehow, which is not good maybe. Did I rush too much? Let me just check the questions. How's everyone doing? Yeah, it's a bit tricky to get it all in the first go. But that's why it's useful to have a recording of someone doing it, so you can just keep trying, going back to the instructions, mess up, try again, go back. That's how we learn these things. Okay, and this is another one that you guys can try. There's no way we're going to get this one done in time because there's 3 variables here. Okay, I mean, we could try it. De Morgan's law. Okay, I guess this is somehow going to use De Morgan's law as well. This De Morgan's law just shows us how to rewrite a statement with a negation on the outside. And I think we saw this in learning unit 3. If you have a negation on the outside of a bracket like this, with an or an and, it somehow just distributes itself almost like a negative sign, and it changes the or to an and or and to an or. All right, so that's all that De Morgan's law does. It just works on these types of statements with ors and ands. Okay. All right, so let me see. Deductions. Okay, that's a new thing. We don't have time for a new thing. It's quite straightforward, but yeah, we'll get to that next time maybe. And I think we're almost done here. So let's see. Do you guys want me to try to finish this in 3 minutes? I don't have to talk much. I can just do it. Will that be helpful to you guys? Just give me a thumbs up or something if you want me to do that. Okay, we got 2 votes. That's good enough. We got a few votes. All right. Okay, let's do it. Are these statements logically equivalent? So we have a P, Q, and R. P, Q, and R. Okay, so here they don't give us in terms of words, which is good. We just need to just write the things down. So let's just go P, Q, R. Then how can we increment this further? We can take a P or Q. Then we can make the P or Q with an R. Perfectly fine. So we've made the first one. Second one, we need to now make a P, if P, then R. Then we need a if Q, then R. Then we can make the final big statement. PR or QR. Okay, yeah, this is going to be a big one, and we're going to have 8 rows here. So let's just stop complaining and do it. So that's 1, 2. Okay, also if the time runs out, guys, I'm just going to finish it anyway for the recording. But if you guys need to go anywhere, do anything, feel free. No stress. I know how it is. Okay, so I'm just going to fill in the first 2. The first 3, sorry. True, 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 true. false, 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 false. Then I just half them. True, true, false, false. True, true, false, false. Half them again. True, false, true, false, true, false, true, false. Okay, the first we look at an or, and or is true as long as one of the things are true. So we're dealing with P and Q here. So I'm keeping my eye on the first two columns and checking if we get at least one thing true. Let's change color for this, shall we? Let's make that true. All right, we have something here, true. Here we have something, have something, yes. Last two, there's nothing true, so false. Okay. Now this is going to confuse me a little bit. So this one is going to be true if the order is mixed up too, which is even worse. So the first part always needs to be false. Change color for that. First part needs to be false. Second part needs to be true. So once we have that, it shouldn't be too bad. As long as I match these, at least one of these, then I write true. Okay, so where do I match these? First one, I make a match. Second one, no match. Third one, make a match. After that, not a match. I found a match here. No match. Match here. Double match, I guess, yeah. And another match here at the bottom. So whatever I don't match is false. Also, I'm going a bit quick with this, guys. So if I make a mistake, just bear with me. You'll be able to see it in the recording. Okay, then if P, let's change color again. I'm going to run out of colors again, of course. Let's go orange, weird color. Okay, PR. So where's P and R? So we need P to be false or R to be true. Is that right? Yeah. So let's look for matches there. First one, I find a match here. Second one, no match. Third one, oh gosh, why is that happening? Where was I now? Confused myself. Okay. Third one, match, yes. Fourth one, no match. Fifth one, match. Double match. Single match. Double match. And single match. Okay. So I should have been filling it as I went, but that's okay. I'll fill them in now. So that's true, false, true, false, true, 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 true. Okay. Now for Q and R, I do the same thing. Let's put this weird yellow. Let's get it out of the way. Q and R. So we need the first one, which is Q, to be false, R to be true. Q and R. Okay. So where do I match? First one, match. Next one, no match. Double match. Next one. Single match. Single match. No match. Single match. Single match. All these colors are confusing me already. But it is a bit helpful actually. True. False. True. 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 False. True. True. So you guys see, anywhere I have a circle, I'm just saying true. Because the circle is where I did the work already. So this last part should be straightforward. I don't think I even need to do any tricks here. Let me just make a color. Pick, oh, we did green already. Dark, ugly green. Let's just go red again. Okay. So this is an or now. Or is true as long as any of these things are true. So we're just working here now. Okay. So we have a true for the first. Is that right? Yeah, we have a true there. No trues here. Have a true. Have a true. We have one. We have one. And we have all over the place. Okay, so the truth table is done. The question asking, is this and this logically equivalent? Are they? Let's check. Are they the same? First row matches, second row matches, third row matches, fourth row doesn't match. So here we lose it. Everything else Now here we also lose it. Okay, so it's almost equivalent, but a few of them are not matching. So no, not logically equivalent. Okay, so let me now leave the floor open for questions. Sorry guys, I went a bit over time. But anyway, it's in the video now at least. Okay, I'm going to be here up until 10 past. So if you guys have questions, you're welcome to ask. Anyone who wants to leave, thanks for your attention, guys. I appreciate it. And I will see you guys next week, hopefully to finish all the syllabus. And then we can do revision afterward. All right. Thanks, guys, and have a good one. I will catch you next time. Thanks, David. Good night.